Hello class, welcome to Big Bang Data Science Solution, the free program, 10-week program. This is the last and final session, and we should be done with this training program. So again, as a recap, in week number one of the session of the program, or the session number one, we talked about why you should learn data science. Then in week number two, we talked about the business analytics and business understanding. Then week number three, we talked about an introduction to Python for data science. Then in week number four, we talked about the second phase of course, the understanding data and explore data analysis. And they believe we had week number four, 5 and 6 and 7 is all around the same topic. And then we moved into data preparation, pre-processing. Then we learned about supervised learning. And finally, we are going to do many algorithms. We are going to do support vector machine. We are going to do k-nearest neighbor, logistic regression, and naive Bayes all in once today. And that should be done. I was planning to do model deployment, but because of the number of attendees, unfortunately, it's discouraging. So we have to stop here. So that being said, again, if you, since today is the last session, if you are interested in a certificate, we can definitely provide you a certificate, but there are two conditions. So number one, you need to pay three conditions. Number one, you need to pass an exam. Number three, you need to work on a project. We are going to provide you a project. It's a 1 month project. And number three, you have to pay $50 for the certificate. Unfortunately, it's a free program, but the certificate costs the business a lot of money, and we cannot afford to do that. As usual, we are going to use the Jupyter notebook, and the first thing we got to do is import the libraries we are going to need. NumPy for numerical Python, Matplotlib for data visualization, Pandas for analytics and data manipulation. Seaborn is used on the top of Matplotlib for data visualization. And of course, sometimes you are going to get some warnings. It depends on the system, depends on the version of the Python. Sometimes you are going to get a warning of certain modules or libraries. So always, unless there is an error, we don't care about the warnings. So after that, we are going to import our data. So this is our data. This is a pre-processed. This is good to go, clean, good to go, all zeros and ones, as you see, except that we have some, probably we should make everything between 0 and 1 rather than having a 0 and 1. Just in case, to avoid any bias. We look into the shape. We got 1,000 claims and 34 clean or ready to go features. The M4, there is no missing values. We already did that. Descriptive analytics, we got all the statistical analysis for our features. Then, of course, we need to take a look into our target variable. Our target variable is the variable that we are trying to investigate and find a solution about. So we decide to investigate if a claim is going to be fraudulent or legitimate. And once we have that knowledge, definitely we can make a decision on any future claims that we have not received yet. So as for all machine learnings, especially using the scikit-learn, we need to identify X and Y. X is a variable, is a list of variables that you are going to use to make a prediction, and the Y is the variable that you are trying to predict. So X is predictors, and Y is the target to predict. Okay, and also we talked about how to split. The second step in the process is split the data. You could split into 20%, 20%, 80%. You could split on 70, 30, whatever percentage that you want to use is up to you. But just make sure that what the training or the part of the data that you are going to use for a trainer model should be larger enough than the part of the data that you are going to use to test how good your model is. So, but the most common percentage, splitting percentage is 20%, 80%, 20%. Okay, so we got that. And since we are doing, modeling, we are doing prediction, we have to have something that we need to compare our models to. So we have to have something to compare our models to, and that is what is called baseline model or a dummy model. Baseline model and dummy model is simply whatever you have exists in your data. So this is what we have. So we got 75% legitimate and 25% fraud. So this is the fact. This is what we have in the data. So, and if we were to use what we have in the data to make a guess, on a future claim, we could say that whenever we have a claim, it is 75% legitimate and 25% fraudulent. And of course, 25% is too much. This is way too much, to make it's too much. So we want to increase. Yeah, so we want to reduce. My bad. So yes, we want to transform this into guessing. So it's going to be 75% and 25%. And of course, 75% decision, and we could be so we make a decision at 75%, but we could be wrong at 25%. But being wrong at 25% is too much. We need to reduce being wrong at certain percentage. We need to get to drop it. So they brought you in as data scientist, and they want you to use the data, find the hidden patterns, find the mathematical relationships of the elements of your data, and use whatever you learned to determine an output for a future claim. So we want to do better. We want to do better than guessing. So for guessing, sorry guys, I need to fix my chair. For guessing, I'm gonna guess 75%, but I have 25% chance to make an error. So this is our base. This is what we are gonna compare our model to later. Any questions, concerns, please? Any questions, concerns, please? We have a lot of people in the room, so please speak out. Moali, Naga, Noreen. Do you guys have any question, any concern, please?
No questions.
Good. Okay, so let's proceed. So yeah, we split the data, and now we have to build. We are going to build the dummy model, which we already did. And so we are going to import from the scikit-learn library. We are going to import the dummy classifier, and we are going to predict the most frequent. We are going to predict the zeros because we have 75 zeros. We want to make sure, we want to see if we are going to get closer to what we have already in the data. And that is what I'm expecting to have. So this is all zeros. We are predicting the most frequent, and it's actually 72. We got, so it should be 75. I don't know why it's we are having 72. So then we learned how to build the first model. Yeah, yesterday we talked about the decision tree. Few things. So number one, we are going to import. This is number one. We are going to import the classifier. We are import the classifier. Number 2, we are going to initiate the classifier with the minimum parameters. Number 3, we are going to fit or train on X and Y. This is train of our 80%. Okay, and number 4, we are going to predict or test on X only of the 20%. So we are going to hide the Y. Why is that? Because this is why we're trying to investigate. This is why we're trying to learn. We built a model on 80% of our data, and this model, it learned an algorithm. It learned a function, mathematical function that represents the true relationship, the approximation relationship of the elements of the data. But we don't know how good or how bad or how great or how efficient what we learned, what the model learned. So we are going to trick the model. We are going to give it the data that we know. We have a target variable for that data, but we are going to take out that target variable, hide it for a sec, and we are going to dump only the X, the predictor, to that model. And the model, of course, is going to apply what it learned from the 80% on this data, and is going to try to make a prediction. And based on what it learns from 80%, and we are going to compare the prediction with the actual using what we called yesterday confusion matrix. So let's do that. So we import, initiate the model, feed the model, test the model, and now we are going to do confusion matrix. We are going to import confusion matrix. We are going to build the confusion matrix, and of course we are going to calculate the accuracy. So yesterday was 80%, and today yesterday was 85% because we had a new data set. We were using a different data set. I believe we were using the version number 3 yesterday. So I don't know if we have that. Let me see. If we were to do a V3, no, there is no V3. So we are going to keep the V4 version 4, but it's 82. Yeah, 82, and of course there is a lot we can do to improve this 82. 83, lot we can do. We could at the parameters level, we could change few things. We could use the Jenny. You guys remember there are 3 methods that the machine decision tree uses to split Jenny index, entropy, or classification error. So run it again. So for the entropy was 599 millisecond. So it's entropy is much faster than Jenny index, 798. The test is the same. And now calculate the confusion matrix. We got 9 and 25. We got 9 and 25, so it does not really. The only difference between Jenny index and entropy in this case is the time to build a model. It's faster for the entropy versus Jenny index, and we could do a max date. Let's start with 4. Let's do stop at 5. Let's see what's gonna happen. So you get 18 and 20. That is too much, and of course it's gonna go down. How about if we were to stop at 3? But if we were to stop at 3, this is too low. So we are going to end up underfitting, not overfitting. So we want just somewhere in the middle. If we were to do 3, for example, but this is very low. You see, you got 40. I mean, we did a very bad in the in the true. Sorry, false positive, false negative. Okay, calculate is going to be around 7. I mean, we are doing worse. It's underfitting. If we were to do, for example, change that and play about these numbers. There is a better way to determine this. A better way to determine the numbers. It's called using the parameter tuning, grid search or random search. But there is one library. It's called Aptuna. Aptuna. It's a library that I start using recently to optimize those parameters. Okay. So let's do 7. We are going to stop at 7. You got 14 and 20. You got 30, 34 errors. 83 still. Okay, and now we are going to move into naive Bayes. Naive Bayes is another algorithm. Naive Bayes is another algorithm that you could use. As a matter of fact, there are a lot of algorithms that you can use. Okay, and unfortunately, this is a very short training program and concentrated on the classification. Supervised learning, because we have a target variable and we are going to do classification. Because we have a binary target variable. We started with decision tree and we spent time understanding what is happening at the back end mathematically to find a hidden parameter. Unfortunately, we don't have time to explain the story behind naive Bayes, logistic regression, support vector machine, kernelized support vector machine, k-NN. This is all different algorithms learning using different learning methods. So naive Bayes and logistic regression, they are learning using the probabilistic method. It's a probabilistic based learning. Now, let me see if I have it here. No, I have it in a different slide. K-nearest neighbor using similarity. Support vector machine, I believe it's using the error-based learning. So we are going to run. I'm going to simply take you over the code and run it. But it's the same process for all these algorithms that you see in front of us. The first thing we got to do is, number one, identify x and y one time, then split one time, import the library or the modules we are going to use, then initiate the model, then train the model on 80%, feed the model on 20%. Feed the model on 80%, test the model on 20%, compare the actuals versus the predictions, and calculate the accuracy of the model. Very straightforward. Any questions, concerns, please? Any questions?
I'm good.
Yes. Yes, ma'am. You have a question?
I'm good. I said I'm good.
Okay, good. Thank you. You are very active, and you name yourself attendee. Yeah, I wish you, but you are a very active person.
Thank you.
I like that. Okay, naive Bayes. Some of these algorithms, and by the way, some of these algorithms require some of these algorithms require scaling. What is scaling? And we talked about this in one of the sessions. So some of these algorithms require scaling, especially the probabilistic models. They are, if you don't scale your data, large numbers always will drive attention of the model. The model might think that the elements of the data with large numbers are more important than elements of the data with small numbers. So $5 is better than $4. 20 is better than 10. $100 is better than 50. $100 is better than $99. Just $1 difference, but yes, it's better. So we want to make sure that all the features are in the same scale. So we want the model to treat every element of our data with the same exact method or the same exact concentration and focus. Otherwise, larger numbers will dominate over the small numbers. So some of these models, they require scaling. Some of them, they really don't care. Like decision tree, it's a very easy, straightforward algorithm. It does not care about scaling. It does handle categorical and numerical efficiently. It does handle missing values, outliers efficiently as well. And so, but there is a problem with it. There is a cause and pros for each and every model. So what is scaling? Scaling is simply changing the range of your data. Let's say we have for salaries, for example, you have salaries for you're working for a company and you're trying to analyze salaries, and you have salaries, or you have a column called salaries from 50,000 per annum to 600,000 per annum. If you were to use this column in a probabilistic model, then of course the 600,000 they are better than 50,000. But and since it's probabilistic model, it does differentiate between the value of the elements of the data to avoid having, and that would create some bias in the end result. To avoid this scenario, we need to scale. We need to put everything between 0 and 1, or -1 and 1, or -3 and 3. There are different measurements. So to scale, we are going to import from the scikit-learn the same library that we talked about, scikit-learn. And so we are using classification, but also we are going to use preprocessing. You click on preprocessing, you are going to find scaling, normalization, encoding, discretization, a lot of beautiful techniques that you could use to bring your data to a certain shape that you can utilize for analytics. Okay, so let's scale. So we are going to import, we are going to initiate, we are going to fit, and we are going to transform. Transform what? We are going to transform only the X. Training features, testing features. And when we split the data, our data, so this is our data. And this data, we got 1,000 feature by, I believe, 43. I'm sorry, 1,000 claims, 43 or 34, I don't remember, features. So randomly, we split on 80% and 20%, and we split on X and Y, and of course X and Y. So we name this training feature, and we name this testing features. So we imported this the scalar. In our case, it's standard scalar. We initiate this the scalar, then we fit, we overcome, we override we override the training feature of 80% by applying the scalar by the same feature by scale. Then we are overriding test feature with the test feature scale. Why do you think why we are only scaling x, we don't scale? Why we did not scale? Why do you think we should not, why we did not scale the y of our data? Any thought?
Or maybe for normalizing?
No.
No?
We want to learn the behavior of y.
Yeah, say again.
We want to learn the behavior of y when we on.
That is true. So we cannot change anything. Now this is in the scene, in a crime scene, you cannot change anything related to this scene. Otherwise, you are going to change an evidence. You cannot change evidence. So this is why we're trying to investigate. We are trying to investigate the why. So stay away from your why. Leave it as is. There are two cases where you can jump in and do something for the why. And I'm gonna name them. You can take a note if you want. So number one, if you are doing classification, the only one time that you can change your y if it's imbalanced, if it's not balanced or imbalanced. Okay, number two, if you are doing regression, the only time that you can jump in and fix your target variable if it's not normally distributed. Apart from that, leave your target variable as is. You cannot scale it. You cannot change it. The moment you change it, you're changing something and the evidence, and you can. Your investigation is not going to be accurate. So we are going to scale our data, and now we are going to. So this is
Before you go there, how we know the imbalance?
The imbalance. Good question. So when we looked into the target variable, when we looked at that is very important things to investigate when we visualize our target variable. So this is our target variable, and as you see, it's normal. But if you were to see something like this, if you were to see this is 0, for example, and this is let's say 1. So 99.99 is 0%, is 0, and 0.001 is 1. This is imbalanced. So whatever, if you don't imbalance it, whatever prediction you are all your prediction is going to be in favor. I'm sorry, not in favor. My apology. In favor of the 99.99. So your model, your prediction is not going to be accurate. So you have to balance it. Clear?
So how we do that? What are the
It's a
methods?
different story. How to balance it?
Okay.
Methods. There is one we call oversampling, undersampling. Yeah, there are sampling method versus undersampling. There are two methods. There are actually more than two methods, and that is something we learn in this program, in the fall program.
I see. Okay, thank you.
In the fall program, we have 1 week. I'll show it to you. Where is it? Factor analysis ensemble. Yeah, we got here class imbalance problem. We got one session talking about it. Okay, for imbalance, there are many methods, and this is a presentation from the program. going to share a few things with you and we proceed.
Thank you.
You're welcome. So this is the balance. One method is imbalance. So we got an imbalance in there. Rare event. So we could do sampling. We could cost sensitive method, current and active learning method. We could do oversampling. We could do undersampling. We could do cost sensitive method. There are many methods. One class learning, novelty decision method, Mahalanobis, rank matrix, and multitasking learning. There is many methods to handle this imbalance, but the most common ones is either undersampling or oversampling. And this is one way to handle, this is one only time, as far as I know, that you can jump in and do something for your target variable. Other than that, you need to leave your target variable as is. Don't change it, don't alter it. The moment you do, you lost something. Okay, so we are going to scale. So before we scale, let's take a look into our data. Yeah. So this is our data. As you see, we got zeros, ones. Yeah, got zeros and ones. And now we are going to scale. And here, this is our scale data. It's all between -1 and 1. So now everything, all the elements of the data would be treated with any algorithm with the same way, the same perspective or the same focus. Whereas in the previous data set, ones are better than zeros. Okay, and now we scaled our data, and now we are going to import naive Bayes. We are going to initiate naive Bayes. We are going to train the naive Bayes on the 80%. We are going to test naive Bayes on 20%. We are going to compute the confusion matrix. And we are going to calculate the accuracy. It's the same process. Okay, let's do that. We are going to import, initiate, and learn. Then we are going to test. Look into the confusion matrix. Here we go. Okay, so let's compare confusion matrices. So this is decision tree. So we got decision tree, and of course we made 34 errors. And now for the naive Bayes. Naive Bayes, we made 50 errors. So decision tree way better than naive Bayes, but still there are a few things that we need to learn about naive Bayes. Okay, so this is naive Bayes. In naive Bayes, we are doing better. We are doing better on the true, this is false, positive. But we are doing very bad in the false, negative. And as we mentioned earlier, these are very expensive. So when you are building a model, pay attention to these values. We want less numbers, less errors in the false negative, because this is costly. It's going to cost you a lot. And y, and now we are going to look into the prediction, is 75. Is the same as the guessing. So naive Bayes, it's called naive because it assumes that your data is an independent. Yeah, it assumes that your elements of your data are independent, and it's really hard to find independent elements of data. So and the naive Bayes does and naive Bayes it does use the Bayesian theorem, or the conditional probability. It does a very good job if and only if your data meets the requirement. Means your data does not have any, the elements of your data does not have any correlation. It's independent. Okay, we are going to move into another model. It's called logistic regression, and it does use the probability. And logistic regression, what it does, for our target variable, which is a binary. So we got fraudulent claim, and it's a binary 0, 1, 1, 0, 0, 1, etc. So logistic regression is a method that we use to transform this binary target variable into a continuous target variable. So this is a binary, is going to be 0 or 1, and it's going to transform this binary target variable into continuous target variable between 0 and 1 using what we call logic function or sigmoid function. So we are going to have 0 0.09, 0 0.9, 0 0.07, 0 0.7, etc. So this is a binary, and now after transformation is a continuous. That's why it's called regression, or logistic regression. Regression is when you have a continuous target variable. So we are going to import logistic regression from scikit-learn. We are going to initiate the model. We are going to build the model in 80%. We are going to fit the model in 20%. We are going to compute the confusion matrix and calculate the accuracy. Very straightforward. Import, initiate, build, test, compare. Accuracy is 83.5. 83.5. And this is the confusion matrix for the logistic regression. Logistic, and this is how we make a decision later. So we got 20, we got 33, we got 50 errors, 34. So logistic regression so far is the best, is better, except the decision tree is better in the in the false negative. Okay, and now we are going to do support vector machine is an algorithm, is used for classification and for regression at the same time. So what it does, this support vector machine, when we plot our data into 2D, so if we were to plot this 1,000 claims into 2D, okay, if we were to plot them, how many classes that we have in this 1,000 claims? How many classes? Can anyone tell us how many classes that we have in 1,000 claims?
2 classes.
Legitimate and fraudulent.
Sure. So if we were to plot them, we are going to see 1,000 claims, either legitimate, L, 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 L. This is what you are going to see.
Like a scattering.
Yeah. You could see something like this, fraudulent, fraudulent, fraudulent. Okay, or you could see something like this. So we got 1,000 claims. We got 1,000 claims. You could see some of this. So you could see, I mean, either first shape or the second shape. There is no probably there's no third shape as far as I know. So the first shape, as you see, we can separate the blue from the red using a line. Can definitely separate using a line. Okay, you could use this line is called the model. You can use many models, many lines to separate. Of course, with some errors, we are going to get some errors here and there. So if your data can be separated using a line, your data is linearly separable. For this one, this is non-linear. It's really hard to separate your data into, so you are going to get a lot of errors. So for just this line, you got 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. We got 4. We got 11. For this one is 0. So if your data is nonlinear, it's hard to linearly separate them. And separation here is the model. So support vector machine, what it does, it tries to find one elements from the fraud class, and this one element it's a fraud class, but it's very close to be legitimate. So probably this one, it's a fraud, but it's very close to be legitimate. And for the legitimate class, this we are going to find one elements that belongs to the legitimate class, but it's very close to become fraudulent. And the model is going to use these two as an extreme. They are called vectors to build a hyperplane. We are going to build a hyperplane. And of course, we are going to build the best. We are going to build as many hyperplane. If we were to take these two, we could also take this one and this one and build more hyperplane. But the best hyperplane is the hyperplane with the highest margin. So that is in a nutshell what this support vector machine is going to find the best hyperplane that can separate legitimate, is going to learn the best hyperplane, we call it model for now, that can separate legitimate from fraudulent. But if it's linear, if it's not linear, then we need to retransform this data into 3D. So we are going to import support vector machine. We are going to initiate the support vector machine. We are going to fit support vector machine. Then we are going to predict. We are going to calculate the accuracy, and we are going to calculate the the confusion matrix and the accuracy.
Before we move forward, yes, I'm good. You are on the scatter plot for a moment.
Yes, I deleted it. Sorry.
Okay. I was just wondering why we have a negative y's in there.
Negative where?
Why the value of y's are in the lower quadrant?
This was
When
just
we go to the scatter plot.
simply trying to explain the concept.
Okay.
Okay, so this is support vector machine. We got 18 and 25 is 33. But we are doing better in terms of it's 18 versus 21. It's better. Okay, and now this support vector machine, as I said, works with, if your data is linear, means we can separate the class of fraudulent from the class. We can learn how to separate the class of fraudulent from the class of legitimate using a line. So we need to set the kernel equal to linear. If your data is not linearly separable, you cannot separate your data. We are going to use a different kernel. It's called RBF. It's the same model, but the kernel is different. So let's build a model with different kernel. And there are more than 3 kernels that you can use. So we initiate, we import, we initiate, we train, we are going to test, we are going to compare the confusion matrix, and we are going to calculate the accuracy is 79. So that is a sign that your data is linearly separable. And lastly, we are going to do k-nearest neighbor. So, and this is kernelized support vector machine, and we got 42. Okay, this is probably worse. Yeah, no, the neighbors is worse. So, k-nearest neighbor is the concept is very simple. Very simple. I am I am a smoker. Afifa is my friend. Afifa is a smoker. I drive fast, or I play soccer. Assad is my friend. Assad plays soccer. That is a nearest neighbor. So with the k nearest neighbor is we are trying to find, it's not an algorithm. What it does, it simply build a lookup table of all of the elements of the historical data. And when you have a new claim, it is going to compare that new claim with, is going to find which claims out of 1,000 claims that we have, it's very close to the claim that you the new claim. Give you an example. Let's say that we have a small data set. So we got population, we got income, we got happiness, for example. We got Spain, we got Morocco, we got India. Spain, let's say income is 80,000 per annum per person. Morocco is 40,000 per annum. India, let's say 110,000 per annum. Happiness is 7 out of 10. we don't know, is 5 of 10. And you are a data scientist, and we want to predict what would be the happiness value for Morocco. Okay, using k-nearest neighbor. So we are going to compare Morocco to Spain and to India. And based on your comparison, what would be the value for the happiness for Morocco? Anyone?
What was the question again?
Yeah, we are trying to predict the happiness of Morocco by comparing the Morocco with Spain and with India.
Closer to Spain, because physically closer.
No, we don't care about physically. Let's take that. Okay, let's do Singapore. Singapore, Morocco, India. Singapore they are making 80,000 per annum per person. India is 110, and Singapore is 7 out of 10. India is 5 out of 10. We want to determine what would be the happiness level of Moroccans.
Should be higher than like Singapore, based on the pattern from the data.
No, we are trying to find the closest. That is called K nearest neighbor. K
Okay.
nearest neighbor. What is the nearest neighbor to Morocco?
It's Singapore.
Singapore.
Yeah,
In
we
the
got
income-
40. Yeah, we got
income
40,
range.
80, and 40. And it's closer than 110 and 40. All right.
That's
So,
correct.
and so K here is equal 1. Means we are using one neighbor to compare to Morocco. What if you have 1,000 of other, 1,000 of other countries with their incomes, and you say, so the first thing you gotta do with k-nearest neighbor, you need to determine how many neighbors that you want to compare Morocco to. If k equal 1 means we are going to compare it with 1, we are going to find one country that is very close to Morocco. K equal 3 means we are going to find 3 countries that are very, very close to Morocco. And let's say that, Iraq, we got Algeria, we got South Africa, we got Mexico. And we got 70, we got 40, we got 120, and we got 40. We got 7, 9, 7, 3. Okay, now what would be, and we are trying to find 3 neighbors closer to Morocco. So which countries they are very close to Morocco?
The Algeria AL is almost the same.
No, I'm talking about 3 countries.
Mexico and Algeria.
So
And Iraq.
it's Mexico,
Iraq.
And
Algeria, and we got Iraq.
And
Iraq.
Iraq. Correct.
Yes.
Yep.
So what would be the value of Morocco?
It could be something like 9.
Average of those?
Yes, sir.
Okay,
Yes,
so
it's gonna
80,
7
divided with 50.
plus 7 plus 9
plus 9 plus 3.
divided by 3, that you are going to get a number. So if you
6 point something.
yeah, it's going
Goes.
to around that, yes.
6 point something. Yeah.
Okay, that is it's an k-nearest neighbor is not an actual algorithm. It's called lazy learning, lazy model. It does not fit like compared to other models. So we are going to import the k-nearest neighbor. then we are going to set, we are going to look for 7 neighbors for every, for our 20, for 20%, we are going to build a model and we are going to find the 7 nearest neighbors for every single elements, every single claims of our 20%. And once we find for claim number 1 of 20%, we are going to give 7. We are going to calculate their mean to get a value. And as a matter of fact, if you are doing a regression, we are going to do the mean. If you are doing classification, we are going to do voting. Okay, voting means if you have 3 zeros and 1 and 2 ones, you got 5 neighbors, 3 zeros and 2 ones. So which one is going to be the winner?
Zeros.
It's going to be 0. So if your classification, we are going to do voting. If the regression, we are going to do an average. Okay, so we are going to, you need to play around the number until you find something meaningful. Always try to make it an odd, like 3, 5, 7, 9, 11. Otherwise, sometimes you might get a conflict. So import the library modules, set the model, feed the model, train the model, feed the model, test the model, compute the accuracy or the confusion matrix. And now, so this is the k-nearest neighbor, and we have to calculate. We got 31. As you see, it's now is the better. So we got 31.
41, Mohammed.
Sorry?
41.
Yeah. Oh yes, thank you. I was surprised. Yes, it's at 41. My apologies. 41. Now we are going to do comparison of all these algorithms, and this is what we have. And we just built models with the default parameters. So now we got a clear map of what we have. Decision tree, naive Bayes, logistic regression, support vector machine, kernel support vector machine, and k-nearest neighbor. And these are the confusion matrix, and we are going to concentrate on the false negative. This is very important. And now we are going to compare the accuracies. We got 83, 83.5. We got 2, logistic regression and support vector machine. So probably these are the models we are going to pick, and we are going to improve by applying the up to now method, or we could do a grid search, we could do random search. There's a lot of algorithms that we could use to fix it. So now we built models. Then we are going to pick 2 models or 1 model. Then we're trying to find the helper parameters. And finally, we can deploy this into production. Okay, folks, any questions, concerns, please?
Good.
Any questions, concerns? Yeah, I'm going to pass this. There's a lot of methods that you could use to visualize how good the model is doing. Let's take a look into a few things. And I'll dismiss you guys. So this Eli 5, Lime, Yellow Brick, MLX extend, some libraries that you could use to actually understand what happened behind the scene of these models, how these models come up with a conclusion of 14 versus 20, 37 versus 18 versus 18, 13 versus 18 versus 133. How do model come up with these different numbers? What happened behind the scene? So these libraries will help you to visualize. It's not working for, yes, here we go. So these algorithms, like for example, the support vector machine, SVM model, support vector machine, uses the insured hobbyist chess. So the best predictor, the best feature that this model used is the insured hobbyist chess. Imagine, if you were to ask you what would be your guess in terms of the best predictors, you could see probably age, the model, the R model, the history of the driver. There are so many things. You will never probably think about the hobbies, but the data tells a different story. Okay, so these are the models. There's the feature that the model uses. This model and the weight is 65% of the importance of the focus was given to insured hobbyist chess because it's important, or insured hobbyist chess was a 65% important feature to determine if a claim is legitimate or fraudulent. In other words, if you call me today and I would ask you one question, what was your hobbies? And if you say chess, I'm going to raise the flag. If I were to keep only one feature.
Is this a real data though?
Yes, it's masks, real data, but mask. You wouldn't tell where it's
Correct.
data,
Yeah.
but you won't tell the company.
Correct, sure. But that fact, chess
Yeah.
players are the most likely to cheat, or
Yes. Yeah, that is.
fraudulent.
I mean, how can you explain that when the psychologist?
Okay, good.
It's really hard to tell. Why.
Not for data scientists to figure out.
No, I mean, you cannot figure out. We need someone with the domain knowledge. Why?
But data scientist is needed to uncover that out of the vast.
My job is to give you this information.
Right.
Find them,
Uncover.
uncover them. Yes, by explanation, it's something. It's not my job. It's not my
It's a
business.
different research. Yeah.
I cannot tell you why insured hobbyist chess is an important feature to determine if a claim is legitimate or fraudulent. There is no way you can do that. So we need a psychologist or someone who knows how to dig deep into these features and give us a logical answer.
And I spent a lot of time trying to teach my kids chess, but they would never learn. So that's a good thing.
I don't know, honestly.
I feel good. Okay. Anyway.
But I guess it's bad for you.
It's all right. I'm past that. I'm like, my personality is already formed, right? The kids, you're hoping that they turn out good.
Actually, there are two hobbies, the chess and the CrossFit.
Yeah, that too. CrossFit.
Yeah.
Okay.
There are two hobbies in there.
But it's very interesting to see that it's real data. This is real life.
Real data. Why?
Mm-hmm.
Who knows?
Yeah. Who knows? Yeah.
So,
okay,
but there must be a reason. There must be some logical, mathematical reason that we need to investigate further down the road. It's because they are chess. They use their brain. They are very smart.
Yeah.
It could be. When they are smart, you think you are going to pass the red light because you are smart. Then boom, It
Yeah.
could be.
Scary.
It could be. Okay, folks. So that's it for today. Before I dismiss you, unfortunately, this is going to be the last day. We can hopefully it won't be the last day. I'm going to be available for the support. So I need your opinion, if you don't mind. Please let me know what you think about the program. What would be if you have any suggestions to improve it, because we are going to do these programs over and over, and I need your opinion. So I'm going to start with Afifa Hashmi. Afifa Hashmi.
Hi, yes, here. I would actually would want to take more of the classes. I don't have a background in IT, so for me, a lot of it was, some of it was like confusing. So I would need to go back. So how you're recording everything and keeping everything in Canvas is helpful.
Sounds good. Thank you. Amin Alwi. Amin Alawi, do you have a feedback, please?
Yes, hi. I would actually share the same feedback. For someone without the background, it can get a little bit overwhelming. And myself, I don't have access to where the classes are recorded. However, I jumped in the middle of it, so I didn't start from the get-go. So I wouldn't give too much weight to my opinion at this point.
Okay.
But I'm now very familiar with the lingo. I can follow a bit, more now that I have the jargon a little bit out of the way, so I can follow more. But I think the concept is rather easy. It's just knowing the steps and knowing the psychology behind them. But it's very informative. It's very stimulating. Honestly, it's very captivating. And I like the way you put it, and I like how you pause every single slide and ask for questions and engage people that are not engaging. I really like it.
Thank you, sir. Unfortunately, this program we have a limited time, and we need to shortcut everything and go straight to the point. In the fall program, we build the background first. Those who don't have a background, we build it. So we spent 1 week on the foundation. Data science foundation. A second week and data science foundation, statistics, probability. Third week, data science foundation, data visualization, and Tableau. Then we start sixth week, we start actual program. So we have almost 5 weeks building the background that you don't have. For this pre-program, unfortunately, we don't have time. If we were to build the backgrounds, we are going to make it 20 weeks or so.
Right.
We got to the
right. And do you suggest that someone, for example, let's say someone were to join next year, for example, what would be your advice to him? Like, go learn Python, go learn, what would be something to make your life easier as a teacher?
Sure. One thing is that you need to bear in mind is data science is a must learn. Mm-hmm. I really don't care from where you are going to get your training. I don't care. But I do care that you need to get your training. So whatever venue you decide to go with, that's your choice. But you have to learn data science regardless. And this is, if you go through the first presentation, you are going to see this ingredient. These are the ingredients that I designed based on my experience that you are going to need if you were to shorten the journey to become a superhero data scientist. So number one, you need to have some domain expertise. You need to have a background. So whatever you are doing better, just stay there and add analytics. If you've been working in finance for many, many years, don't switch the career and try to learn data science. No, just stay in that domain and add analytics into it. You could be better than someone who is purely data scientist. And trust me, nowadays, companies, they are having problems hiring data scientists. So what they do, we have data scientists who could do an amazing job, but the problem is they don't have domain knowledge. So what they do instead is they train their employees. Employees, they know the business. They have a good understanding of what the business is. All what they need is add analytics and they are good to go. It's better for them to train someone with the knowledge rather than bring in someone with skills that don't have a knowledge. So
I read that in the book you shared with me. That actually was one of the strongest points.
yeah. So stay from where you are and add analytics. Number two, you have to master at least one programming language, Python or R. I would, if I were you, I would learn both.
Okay.
And trust me, it did open many, many doors for me. Both, knowing both. So, number three, of course, you need to learn some probability, math, and statistics. Just basic. There are one book that I would recommend. It's called, here we go, Naked Statistics.
Naked Statistics.
Yeah, very small book. I recommend. It has a lot of information that a lot of information you are going to use. Okay.
Thank you so much.
Number four, you are welcome. Of course, you mentioned this earlier. Lingo, foundation. You need to start speaking those big words. Decision.
Fluently.
Just learn this. K nearest neighbor. What is the K? What is NN? K nearest neighbor. What is K nearest neighbor? What is decision tree? You need to know this.
And it even communicates confidence with the clients when they see you fluent like that.
Yeah.
They stop scrutinizing you when they focus on the message or the story you're telling.
That is true. And finally, you have to work on a project, and that's why we
practice
for this 10-week program. It's free, but we offer a certificate plus a project. We have to show me that you deserve a certificate, and we'll provide it to you.
Fair enough.
So this is the roadmap. And I did not learn this in school. I learned this through my training experience. Since so far, I have trained over 7,000.
MashaAllah.
Yeah.
You're good. You're good. I honestly, I'm captivated every time there is a class. I turn everything off and I just focus on it.
Thank you, sir. Yeah,
and I follow as much as I can.
So yes, data science is a mass, and data science is a journey. I'm still learning.
Future. Yeah.
I'm still learning, and I learn a lot. And just the project, I'm working on a project with a government agent. I learned so many things in that project, and whatever I learned, it is going to be added to the batch number 16. This is going to start in August.
Nice. And this is infancy, right, Brother Muhammad? This is like very early stages when it comes to machine learning and AI, right? Like we are in like the early 90s of the internet, basically, right?
Right.
Like, okay, perfect.
The sooner the better. If you wait until we have enough graduates with degrees in data science analytics, it's going to be
it's too late.
It's going to be too late. So you got to start your journey.
Perfect.
Okay, thank you, sir. Asad, do you have any feedback, any suggestions, please?
Yeah, I find there was there were some sessions that I could not attend due to scheduling, but the ones that I attended, I thoroughly enjoyed and learned. So, given that my own situation is that I have some programming background, a couple of years, but this is way back. I'm a little older than you guys, but this is way back 25 years ago. So I need to get back into the real cutting edge stuff. So that's why I find this definitely helpful. I'll try to take the real course. I'm not sure if I can do that just yet, financially, but inshallah.
You can repeat for the finance. We can definitely we can help you. We have payment plan, and you can repeat and repeat and repeat unlimited times until you master the things. And once you do that, then we can help you with resume preparation, interview preparation, and job placement for free.
Okay, thank you. Thank you. That's good enough.
Good. Okay, attendee. Again, I don't see.
Yeah. Yes, Mom. I agree with you. I like the class. As I said before, like, I like the way you explain the concepts to make us understand. Also, I agree with you in one of those points you mentioned, like just before, like we learn while working in a project. I agree with you that because I had that similar experience in my own, like in projects, like in cancer research. Uh, as the other brother said, the lingo and everything, whatever you are doing, it's for free. Even though it is for free, but you are doing your best. I like the way you are doing it.
Thank you.
Keep continuing.
Sure. Okay, Fatima, not Fatima Ali, Fatima. Any feedback?
That's both me, brother. Yeah, I do want to give everyone just a little bit of my perspective, guys. So hi everyone, my name is Fatima Ali. I am the TA / business manager for Big Bang Data Science. I just want to share a little bit background about myself, just so you guys have a clear perspective of everything. I come from human resources background, completely no IT experience whatsoever. Did some programming back in college in the late 90s, hated it. I swore to stay off of programming because back then, programming was not like how it is right now. When I came across, or in fact, when my husband came across Big Bang's 30-week course, I was working for CVS Pharmacy for the corporate office as a patient consultant. It was a very stressful job, did not enjoy it. And I was very skeptical of the program, especially because, $3,500 was a big price tag. And I wasn't even sure whether, I would get anything back from it, because coming from no IT experience, I was like, okay, is this program even going to help me in any way? Where would it take me? But to be very honest, not because I'm working for BBDS, but because my own experience just opened a brand new world for me. The way the program is designed, when you come out of the program, you have a very solid understanding of all the foundational requirements of machine learning and data science, not to mention the real world experience you will gain from working on projects, working as a team, because data science is a team sport. You cannot do it on your own. And it gave me so many skills that I can't even, share with you. It's endless. The confidence that I gained from presenting, the coding skills that I developed, the statistics foundation, the machine learning data science foundation. I knew a little bit of lingo beforehand just because I'm surrounded by IT guys in my family, but to completely and truly understand what it was, this program gave me that understanding. It is a lot of work. I will not deny that. There were some really, really long nights. There were some nights I was crying because my code was not working. But if you keep going at it and if you dedicate yourself, I promise you, you will come out very strong. Just keep in mind that don't expect that you will know everything, because no one can. I connected with people on LinkedIn who have been a data scientist for 10, 20 years, and they still are learning, because there is so much to learn. As Brother Mo said, it's a journey, and you have to just keep going. Take one thing at a time, whether it's starting with one programming language or one visualization platform or just one model. Just take one thing at a time, keep focusing, and just keep building on it. My personal advice, I would highly recommend this program. And until you can decide what I would suggest is sign up for those online data science magazines. There are tons of websites out there. There's one that I personally use. It's called Medium, Medium. Is a bunch of data scientists who write articles on it, and just read one article every day. That's what Brother Mo suggested when I started, and that has helped me so much to build not just my lingo and vocabulary, but to truly understand the different concepts, because this field is evolving very rapidly. There are new libraries, new concepts, new visualization tools coming out every day. And it's sort of hard to keep up with it if you're not directly in the field. So for someone like me or like you guys who are just getting their feet wet, read the articles. Go on YouTube, subscribe to some of those YouTubers who are hardcore data scientists like Krish Naik. He's an Indian YouTuber, really, really knowledgeable, amazing guy. His way of explanation is just phenomenal. There are many like that. Data Science Society is another one. They're very good. So look those things up, build your network, and just learn from everyone and everything. That was my personal suggestion to all of you.
Thank you, Sister Fatima. Appreciate that. Okay, Goal. Do you have any suggestions, any feedback, please?
Assalamu alaikum, first of all.
Assalamu rahmatullah.
I've only taken a couple of sessions. I fell ill, so I really like the way everyone is involved, and the questions that are being asked throughout the class are more helpful in elaborating the details. I like the way of teaching and the way you involve everyone throughout the session. That's really good. And I do not have a lot of background, as I think posted in the forum as well. But I've done RStudio and a couple of statistical analyses as part of, the research that I've been doing in qualitative and quantitative domain. But I'm really looking forward to this batch in August to learn together as a team. Yes. So I'm sorry, I do not have a lot of
Thank you.
feedback here because we've just taken a couple of sessions.
Sure, we'll please go through the recording. I know you have access to the Canvas. Schedule one-to-one session with me if you need help, and I hope to see you in batch number 16 in August. Okay.
I'll be really thankful if any of the members would help me navigating through the recorded sessions, because I joined very late and then I fell ill, and
sure, I can help you, or Fatima can help you to do that.
Okay.
Thank you. Hina Sorahio.
Assalamualaikum everyone. Yes, brother. So I've personally found this course very helpful. So as a fresh graduate with bachelor's degree in information technology and systems and starting career in data analytics. So, something I found a lot helpful was, when I get a data set, how I should look at it and what are the key points I should consider and what are the things like IDs I shouldn't worry about. If they don't add any value, then I should not think about it. But the confusing part for me was when we started kind of going in stats. So, personally, it gave me like a visual representation of how machine learning works, like algorithms and how there is a math behind it. But in the long term, it's just I need to mainly focus on how regression, clustering, how these work. But I personally found it very helpful. It was organized, and just like brother mentioned that, whenever we had a question, when you paused, we got the opportunity to ask. I think, that's pretty much it. I personally learned a lot, as a starting career in data analytics.
Sure, happy that you're learning. If you need help, please don't hesitate to contact me. I'll be more than happy to assist with whatever I can. Thank you.
brother.
Okay, Mazharullah.
Quick question, brother.
Sure.
How long these recordings will be on
At
YouTube?
least for a year.
For a year?
Yeah.
Perfect. Thank you.
Thank you.
Assalamualaikum, Brother Mo. Jazakallah khair for your time and providing the learning path to know how to become the data scientist. So I have spent almost like 2 decades in the information security domain, and most of the product is nowadays come with an AI part, right? So there is no security product which says like they don't have an AI embedded into it. So my intent to what I need to really take from this particular sessions and training was like what are those features that they are building in, how they are really building it, and how they are really creating the model. Because when we see a product from full black box point of view, we don't really understand like what is really going inside the product. So your approach and you have really splitted the so many smaller chunks, like what really goes on each and every the task and stuff. So that really helps, like even how the product are really going to be designed. That provides an AI feature, so that's really helpful. So being in a Java development and Java programmer, I think I might have to really get a little deeper into the Python, and then learn more of the SDKs, and as well as the mathematical functions to identify how I can really glue all these things together to get the best out of the data scientist world. Jazakallah khair for your time and for your initiative. And definitely I'll be in touch with you if I have any questions, and Jazakallah khair for your team.
Hayyakum. Okay, Noreen Zafar, any suggestions, please? Noreen Zafar.
Hello, Assalamualaikum.
Alaikum salam wa rahmatullah.
Personally, I'm the beginner on these course, but I found it really interesting because this is something new. I never heard it before, but from learning this, I found out about. As long as I understand, it's all about data science. Is all about math. It's all about data, and I'm still. I'm very excited. I found I learn new things. Like I didn't know that before. What is data science? Like what it's all about, and I'm still learning. And I attend all your classes, but I'm still learning. I'm a bit confused as well, but I got some. I get understand loads of things which I didn't know that before. And hopefully, and I found you really good teacher. Like you explained really every little detail which the teacher need to explain to the them purpose. So yeah, you did everything what you need to do, and I'm very thankful to you. And you are a good teacher, so keep it up. You did all your hard work and all your support, and I'm very thankful to you. And hopefully I will learn more about, like, the other person saying, read the this and this YouTube, and all your recording. I will, continue to listening and do that. And hopefully I will get to the point when I gonna 10 more lessons, like you're saying you're starting in August, inshallah.
Inshallah. Okay, sister. Thank you so much, and happy to have you in my class. Okay, Saba.
Thank you.
You're welcome, Saba. We got 3 more students, and we should be good to go.
Yeah, I really enjoyed the course. I like the fact that you have given a very detailed overview, and that's exactly what I was looking for, to see if it's a good career fit for me. Because there wasn't any sugarcoating or making it look easier than it should be, because I have signed up for other stuff where people make it sound super easy, but when you really get into it, you kind of get the real picture. So I really appreciate the honest picture that you provide. I would say that I am a little bit intimidated. I'm kind of learning part-time because I have small kids. So I'm not sure if I'll be able to continue, but given what I wanted to get out of the program, I really did enjoy it a lot. It was very interesting. And one question I have in mind is like, if somebody like me who doesn't have the time to invest like full time, but even if I don't take it as a career, I really find it so interesting that I would want to continue learning. So is there a part-time option available? Or like in the long run, do you see any part-time work opportunities in this line of career?
So the thing that I know for sure is data science is the future. If you don't have the skills, if you don't have the analytical mindset, it is going to be very tough. Then you'll end up getting low jobs, working for Walmart, for Home Depot, for just low paid hourly jobs. So either you do it or you are going to pay the price. I know that for a fact. Data science, machine learning is stealing our jobs. Either you learn it so you can keep your job and secure your job in the future, or you are going to hear the music. So in terms of part-time, full-time, right now I'm working on a project that's part-time and I've enjoyed it. How long does it take you to become a data scientist is a journey. It may take you a year, it may take you 5 years, but start as soon as possible. You don't have to take our programs. And there are a lot of programs, free tools online, like Fatima mentioned, it's free YouTube, many YouTube channels, amazing jobs. Just do something for yourself. Just do it. You are intimidated, then you need to overcome that fear. You need to overcome that fear and learn. So learn data science for two reasons. Number one, to avoid being a victim. To avoid being a victim. Number two, to increase the chance of getting a good job. You have a family, this is your chance. You are gonna struggle for 1 or 2 or 3 years, but the remaining years of your life is gonna be beautiful. Or you have to stay away, but you'll be struggling all your life. So the choice is yours. Okay?
Thank you. Thank you so much.
Welcome. Okay, Saliha. Saliha, you are any feedback, please? We cannot hear you, Saliha. We cannot hear you. Okay, Shahid, Zahir, you are the last students. Any feedback, please?
Okay, brothers. Assalamu alaikum, everyone.
Welcome, salam.
First, I thank you for your effort, and it's a big service, I'm sure, for the community. May Allah bless you more and more with the knowledge and wisdom and everything we can think about. Great program, and I was inclined to do that. I'm a self-learner. Majority of the things I have learned myself, and not just learning myself by teaching the others. So that's the way I see it.
Right.
That you learn something a little bit and you try to explain to the others. And when you help them with their answers, means sometimes you know the answer, you do yourself. Sometimes you have to search for the answer, and you get back to them with the answer to the question they have.
That is true.
So few of my sisters have explained well, and they were well spoken about the program, and I really second them their comments on it. Sister Sabah said challenging in the learning. So Sister Sabah, everyone has a life full of the things they have to do. But the best way I learned to learn is that you dedicated a small amount of time on your schedule on a regular basis. Say like open a book for half an hour every Sunday, or watch a video half an hour every Monday, whatever time you have available after you're done with your kids and your family.
That is true.
So that's the way to learn it. We can't be something in overnight. So we have to do one step at a time, small step at a time. Like we learn as a child, we learn how to walk, we learn how to read, and we apply that knowledge. So that's the way we do it. Other than that, the program is a fantastic program. I learned a lot. I never had learned about the data science. I have taught Fortran, I'm sorry. I learned Fortran, I learned COBOL a long time ago in the early 70s. But I have taught C++ and the Python, and anyone, sister, brother need help with from that, feel free to reach me. I'm open. I'm really available to help you out, whoever need help. This data science, I'm learning something. This is just the beginning for me in the data science. And I will watch those videos and read the text which is being posted. And something in the Jupyter notebook, that's a great thing we have in there. So I will use that. One thing I want to suggest, Brother Muhammad, the course was great, but one thing my feeling is that in the Ramadan, we were overwhelmed with the time factor was a big thing in the Ramadan. Sleepy, tired, all the stuff. So what is the possibility of moving this program instead of Ramadan to Sha'ban? So this way we are more alert, more active in the class, and I think we will have a better response.
Actually, Ramadan is the month of sacrificing. That's why we put in. I know. So you sacrifice, you put effort, you stay up late all the way to morning, and most of the victories in the Muslim calendar were accomplished during Ramadan.
I thought the Shaban is the month of charity.
Yes, no,
Ramadan is for istighfar and dua.
No, Ramadan is the month of patience.
Okay. So you
better knowledgeable. We could do it in
Just my suggestion, because we have a lot of things to juggle the Ramadan, the fasting. I noticed yourself were tired, talking long hours in this.
Yeah, and I used to it. This is the 5th time I'm doing this, and I enjoyed it. Yeah, thank you.
May Allah bless you with the energy, man.
Yeah, thank you so much, everybody. That is the end of the program, and
thank you very much.
I learned from you myself. I enjoyed teaching you guys. Hopefully, please spread the word. This is all the least you can do. Spread the word about us, about our programs. And if you feel like you want to learn data science, talk to me, and I will guide you. Either through our paid program or through our free program. I can also help outside the program. You don't have to take my program to seek for help from us. I promise to always help anyone needs helps in the analytics in general. Okay, folks, thank you so much. Hope to see you guys in next batch or in next program. I don't know when. We are gonna definitely we are launching new free programs. We don't know when, but you all can be posted. Until then, you guys have the rest of the week, beautiful week, and assalamu alaikum wa rahmatullahi ta'ala wa barakatuh.
Thank you.
Brother, appreciate it.
Thank you, everyone. Thank you. Nice meeting you.
Brother,
yes.
Do you post information on LinkedIn?
Yes.
Regarding courses? Okay.
Yeah, I'm in a LinkedIn too. Yeah, just search for Mohammed Wani. You're gonna find me.
Yep. Thank you. Appreciate it.
Assalamu alaikum.